All right, hello everyone. Welcome on in. What we're gonna do is we tried earlier today to try to go over our machine learning from scratch, our deep learning from scratch framework that we wrote on stream live. We wrote it live on stream. I wanted to do a review and test. That's part 4. We tried it earlier today, but I only had 15 minutes. I thought I was gonna have more time, but guess what? We have some time now. We have a little bit of time now. We're going to go through the AI and see what it is. What are all the different things? We're just going to walk through it because we've made some adjustments. We made it better. We made it better yesterday just by simplifying a few things. Although it is more difficult to read now, which is kind of unfortunate, but it gives us the ability to give more flexibility. In fact, what we should do is, hey, Echo, how's it going? Welcome on in. We're actually going to walk through our AI framework this time because we tried to go live earlier today, and guess what? We couldn't. We actually did go live, but I had to go. I had other things to do, other plans. But we do have some time now. We have time. We have some time to go through it. So here on our screen, we've got our IDE open and ready. We're going to edit and make any edits or changes. Maybe little like touch-ups here and there, little touch-ups on the screen. We'll find out. But you know what? Actually, before I do that, check this out. There is a file called MLOG. I think this one's just a little more easier to read because it's here. Let's clean it up a little bit. Let's clean it up. Hey, Ashford, how's it going? Welcome on in. We're actually going to walk through so far what we've done in our achievement here. So here's what we had previously. Like this is day 2, which includes back propagation. And day 1 was forward propagation, which is the easy part. And then then we also had the optimization, right? So this is the hard part. But you know what? When I said it was hard, I mean, look at the code. Look at the code on the screen. It's only like a few lines. And it's the hardest part of AI. And you're like, wait a second, I thought AI was super hard, like super challenging. And it is, don't get me wrong. It is. But here's the deal. We made it simple. There is an industry algorithm that has been implemented that is rather advanced in terms of its just complexity. But you know what? You don't need all that complexity. My goal was to show you how simple AI can be. Check this out. This code right here, that we have highlighted on the screen, it is the part where the AI learns. It's the part where the AI learns. It's going to call it back propagation and optimization, which basically just means that you're going to slowly adjust the numbers in the AI to sort of, it's kind of like it's a morphing or a mapping. How do you kind of see it? So the numbers are right here. Here's our numbers. These are what you call parameters. That's a clean code. You got it, Ashford. We got some clean code here, you guys, because it's just super clean and simple. You can have a whole bunch of code. Hey, AJ Ball, AJ Ball, you subscribed and liked. Thank you so much. Happy to have you here. Appreciate all the likes, you guys. Appreciate the likes you got there on the screen. Got the little floaty heart icons showing up there. Thank you. Neat. I think it's super neat. It's just in the industry. Check this out, you guys. The industry, they have these advanced algorithms that just take up way too much code, and you can go crazy and you can write a whole bunch of code. It does the same thing. It achieves the same goal. But you know what? You're ending up with just a whole bunch of debt, a whole bunch of code debt. There are ways to optimize your code to have the least. That's like the best way to do it. Daniel, hey, how's it going? Daniel Ramirez, happy to have you in here. Leaf Gang, how's it going? Good to see you. Good to see it. Is this QLoral training? QLoral, this is just regular deep learning deep learning neural network. This is a deep learning neural network. So it's a step above. So you've got a bunch of varieties of networks. So let's pipe this out on the screen real quick. All right. So you've got let's turn off Copilot 1 second. Copilot disable. We're disabling. Let's see. We've got so you've got ANNs, which is the artificial neural network, right? You got ANNs, and then you've got DNNs, which is the deep learning neural network, and that's what this is. That's what we got here. We've got a deep learning neural network, and you can go a step further. Hey, what is it? Martis? Hey, Martis Nix Jr., welcome on in. Happy to have you here. We're going to do some AI. We're going to we built an AI on stream live from scratch, mostly from scratch. We use NumPy. We use one library, and that just helps us with the for loops, right? The iteration, so that way we don't have to do a lot of for loops on the screen. So it makes things a little cleaner. It's like sugar. It's like cleanliness. It's like happiness. It's just math. We got some math there. You got deep learning. Then you've got, you've probably heard of CNNs, and you've heard of RNNs. You've got RNNs, and then you've got, I guess, TNNs maybe, or I guess like transformers, which is, you know, the chat GPTs. There you go, chat GPTs. You got a whole bunch of different kinds of artificial intelligence models that exists. Let's see, awesome, isn't it? I think it is. I think this is really cool. This is AI. It's just, in the moment I got my hands on some AI and I kind of understood it many years ago, like maybe a decade and a half ago, it was just a whole new world open. I'm like, this is the future. Like before ChatGPT, before any of those LLMs came out, the large language models, I was like, this is it right here. And I was just fascinated, and I had to go deep. I went so deep that I learned all the things, as much as I could, really. I still don't know all the things. There's a lot more to learn. Let's see, convolutional neural network, right? Convolutional neural network, right? Let's paste that. And then you've got your recurrent neural networks. Let's see, recurrent neural networks. So you've got these kind of different patterns. So convolutionals usually to help, it has a bunch of filters. Well, the idea is about they're all numbers, they're all arrays. So when I say any fancy word or term, I'm usually probably talking about an array, like a number of some sort, like just some sort of number. So that's typically what I'm talking about. What did I do here? Oh, this is, okay, so this is the OG. This is OG, okay. Code Bit Cookie, what's up? What is your biggest project you have worked on, even if with a team? Oh, okay. Probably, well, my company here. So my company, pubnub.com. Here we go. Check this out. We're a global infrastructure for communication. We build multiplayer games. We've got over 1 billion connected devices. We do smart TVs. We do home automation. So if you have any like IoT devices or light bulbs that turn on and off with your Wi-Fi, that's what we do. And we've got a huge code base. It's massive. It's written in C and Rust. We got some Python. We've got some Golang. We've got some JVM languages in there. A whole bunch of stuff. A whole bunch of different things. So that's the biggest by far. By far the biggest, because over 1 billion devices are connected, which is a lot of devices. All right, let's see here. Leaf Gang, you asked ChatGPT. What did you ask ChatGPT? To take a simple sentence and show me how behind the scenes it gets converted into a matrix. Oh, how the tokens are converted into numbers. And the next one predicted. Yeah, that's how LLMs work. All right, let's see if we can walk through that really quick. So it's actually kind of simple. So you got a simple sentence like, let's see, input. You've got your input sentence like, hello, how are you? ? And then this will be a token here. So we'll say that's token 1, this token 2, we'll say token 3 and token 4. But these are just sort of annotations of tokens, right? Annotations of tokens, but what this really is a giant array. It's a multi-dimensional array. Maybe it's like, you could say 512. Usually they're bigger, but yeah, you could say 512 like this, like that. We'll go another 512 like that, right? We get another 512 over here, and then another 512. And these are just vectors, and vectors in these, they turn it into tokens. And then also the question mark is its own token. So this is like number 5. Number 5 here. And then we go another, let's see, and then another 512. But sometimes they can go bigger. Sometimes you get much bigger numbers. Turned it so simple, something that I learned in MA 101 and MA 102, yet smart and complex, kind of mind-boggling. It is. It really is. And so this is a 512 element array, and then the array actually just kind of looks like this 0.01123 comma 0.1, like it looks like this, like, but it just keeps going, and so now you've got a vector, and it's an embedding space, right? An embedding space. Ahmad, I'm already created to develop new website code refactor, so many new advanced features on my website neural network. Really? You got to tell us more, Ahmad. Tell us more. I'm kind of curious. What do you got there? What are you talking about? What, neural network on a website? That sounds really cool. That sounds like the best ever. Okay, so we're talking about large language models here. Language, can I spell correctly without the e? Wait, how do you spell language? Am I spelling it right? Let's put that there. Large language models. Input sentence. You got the tokens. The tokens are vectorized in a multi-dimensional, well, in a higher space, right? You've got a whole bunch of floating point numbers. And then it goes into a QK. That's the input. And then you need to do self-attention, which just means that you need to multiply it by itself. So that way you've got, it's like you could say, it's like hello times hello. But then you also have to go further, right? Then it goes a step further, be hello times how. And then it goes hello times are. And then so it takes these matrices like that, and then it creates an attention mechanism, right? It's got full self attention, which means that it's able to relate all the vectors to each other into a single input. And then you've got your input, and then it goes into your input here. And then you finally have an input like this, down arrow, like that. Lots of things. Yes. Okay. Code bit cookie. Yes. So far, so good. The large language model, there's a lot to it. I mean, there's just a whole bunch of stuff that happens to vectorize the data. You have to vectorize the data when you're converting it into numbers, because machine learning models, they only know numbers. And the numbers usually between 0 and 1. The number is usually between 0 and 1. You can go a little bit higher or lower, but then you're going to hit some problems if you do. So you always want to make sure you're between 0 and 1. And so this is what this is about. And then once you've done the self-attention, you need to, usually there's another step that goes into it. It's called positional encoding, or like positional encoding, right? You got something like that, which basically just modifies the values of these matrices so that way it, it's like position 1, position 2. Let's see here if we can do something like that. Let's see if we can show it on screen. Do you have diffusion models on your agenda? Ooh, diffusion. Diffusion's kind of cool because it basically starts with, random numbers, and then it slowly trains the model for every random. So you start with a random number, and then the input is random, which is really interesting as the first layer. And then you sort of slowly adjust it to hit sort of a target image. It's really neat. And so you train it on a whole bunch of images and then a whole bunch of input tokens to like describe what the picture is. And then you can basically, from a diffusion perspective, it allows you to then create any image in the world. That's what like most of these AI models that are generating images and videos, it's based on, I believe, diffusion. I think there's probably some other adjustments that they've made, some more advancements, because it has gone really fast recently. I haven't caught up. I have not been keeping up. But so you can do a position encoding, usually with like a cosine or sine, where it's just a continuous circle. And so you like multiply by 0, 1, like this, like 0.1. But then this one gets multiplied by like 0.5, right? And then it alternates. 0.1, 0.5, something like this. There you go, like that. VY, VP, VY, VP. There you go. I want to make one from scratch and half got the maths. You did? Code bit cookie. Bit cookie? That sounds like a really cool idea. You need a lot of compute, though. Hannah, how's it going, Hannah? Good to see you. Welcome back in. We're talking about artificial intelligence right now. We're kind of going through the stages of the large language model and kind of how it works in the input. So now that you've fully vectorized your input, right? So you started with the sentence, but now you have sort of a positional encoded self-attention blob of numbers. You've got a big giant matrix, which is a blob of numbers. And so you've multiplied everything for self-attention. You've positionally encoded it. Or there's other kinds of like, alternating encoding options, just to help. So what you're doing is you're giving the AI sort of its vision. You're doing its vision processing. Because from a sentence perspective, right, if you're just turning it into numbers like this, it doesn't have a lot of context. But if you vectorize it with an embedding model that has a context, like the word hello, It knows that it's, a greeting. It's a greeting term. It knows that it's not a name or noun, right? It's got like all these like attributes to it. And so that's what the vectorization and the embedding process is. And then from there, it goes into the QKV attention or QKV layers. And these layers are just more matrices, like a whole bunch of numbers, right? And then here's another number, but a whole bunch of other numbers like this. And each like a Q and K and B, they're basically all the same in terms of what their numbers. And so it's more numbers. And this is similar to, oh, hey, Michael, welcome on in. Thank you for the likes, you guys. Appreciate it. Seeing those little icons show up there on the screen. That's really cool. Then you go into QKV, which is similar to a CNN, similar to convolutional neural network, where you have multiple filters, but you treat the filters differently. In this one. What are you doing, bud? This looks cursed. Yes, we're talking about artificial intelligence, meme coin guru. We're talking about artificial intelligence. We're chilling. We're talking about AI and then how the algorithms work underneath the covers. That's what we're doing. Code bit cookie. I got stuck on the maths. That's the hard part. It is. Thank you for all the likes, you guys. It's super hard. Vabel. Wait, Vabel? Vabel. How's it going? Hello, world. You said the right term. You said the magic word, Vabel. Vabel, you said the magic word. Hello, world. There you go. The first word on the internet ever transmitted, I believe was it LO? I believe it was LO, right? Which is basically hello, right? Hello, right? The first two characters ever transmitted on the internet was LO, which basically translates to hello. Isn't that crazy? They're like, okay, let's type one letter, L. And let's type another error. We did it. All right, let's do another letter, O. Boom. First, hello. We did it. Everyone. Isn't that cool? So sine and cosine used for positional encoding instead of any other function. It's because you can use those to do circular, and you can change the amplitude across them. So many likes, you guys. I appreciate it so much. This is awesome. Yeah. So yeah, you could do a lot of different alternating encoding patterns that help the model sort of see things, because what you're going to be doing is when you're training the LLM, you're going to be feeding it one token adjustment at a time. And it's a lot of training. Don't get me wrong, it's a lot. So it's a huge amount of training. And whenever the model spits out its next token, which we haven't gotten to yet. We haven't gotten to it yet. But if you check this out, what is the code to make a main character walk? Hana. Oh, what do you mean the code to make a main character walk? That sounds like it's a lot. It really depends. Hana. Or Hanan. It depends. What do you want to do with the main character? Like, are you talking about like a video game, or are you talking about the simulation? What are you talking about? I'm not sure. Okay, thank you for all the likes, you guys. Appreciate it. And then it goes into these filters here. These filters, which are Q, K, and V, which are just more layers. They're just more numbers. It's all just numbers. How you only got 5K subs content and your voice is really good? You think so? Thank you so much. Well, here's the deal. I've done a lot of video calls and stuff in business, because I've got a business. And so there's been a lot of conversations over the years with many companies around the world, because we have over 1 billion connected devices and lots of customers, you guys, lots of customers. And so we got to talk to them a lot. And so just over the years, you just happened to jump into it. And so now, guess what I'm doing? I'm here with you on YouTube, and we're doing it live. We're hanging out. We're chilling. We're talking about AI. Tello, how's it going? Is this still Python? It doesn't look right. I know. Don't worry. It is. It's Python. This file, it is Python. Look, see right here. Py.p. See right here at the bottom of the screen, .py right there at the very bottom of the screen, right here. That's right there. You got it right there at the bottom of the screen. It is Python. Here you go. How do you make controls for your game? Oh, You can use you need to use input capture. You need all right. You need to do input capture. So on your keyboard, and it's better to use like a framework because you want to see if a key is held down, but you don't want to know when a key is pressed. So you don't want to do interrupt driven. You just need to know if the key is held down because when you're rendering a game, you have a game loop. And in the game loop, it's possible if like a user is just tapping on a key, you don't want them to like, you can't capture that interrupt in a game loop. You have to know whether it's pressed down or not. So there are flags. And so there is a framework that's built maybe like in Unity or Unreal Engine or DirectX or OpenGL input or, DirectX input. How old are you? Good question. The internet has the answer. Awad, the internet has the answer. I bet if you looked it up, you'll find it. I bet you'll look it up. If you find it, you can even ask ChatGPT, and ChatGPT knows. ChatGPT happens to know who I am. Been around on the internet for a little while, you guys, long enough for ChatGPT to know who I am. But yeah, so like in the game world. So let's check this out. Let's do this. Let's see. Check it out. Let's do it. So Unity, C#, game keyboard input flags. I'm pretty sure this is it. We need to get the flags. We need to see, in Unity, there's no built-in flag system for keyboard input. Instead, you can manage the state of multiple key presses simultaneously using C# and Unity's input class. So you can use the input class. The most common approach involves creating a Boolean flags or state variables to track which keys are currently held down. So I was really certain that Unity would automatically make it really easy. So here you go. So key code W, you can get to see if it's currently pressed and held down. So key code W. You want to grab key code W and see if it's currently held down. And then you can update your frame in the game loop to move the character forward. There you go. There's your answer. Game Development 101. There you got it. Could you play some games? Hannah, we could totally play some games. That is something that is possible. I do like playing games. I like playing a lot of games, mostly on, I've got my consoles. I like my consoles because I like to lean back in the chair and like get the controller going and like, yeah, just chill out on the games. I like doing that. I just started a course in machine learning for deep learning. Awad, excellent. Good news. Thank you for the likes, you guys. Good news. Awad, we are discussing that right now as well. And we built a deep learning framework here. It's really easy. You'll have to be really surprised to build it from scratch. It's super clean. If you do it the way I do it, if you follow instructions from someone else, they're going to give you a lot more code. Check this out. Here's the most difficult aspects of it right here. These three functions right here is 100% the code that you need for deep learning, you guys. For deep learning, isn't it cool? I think it's really cool. Stephen L. Blum, you got it, Babel. You figured it out. Stephen L. Blum, yes, that's right. Evening. Hey, a beauty. Good to see you. Been a while. Yeah, I remember. Hannah, how do you make sound in your game? You have different game channels, right? You have different audio channels in your game, and then you want to apply different. I guess you could have you can use different audio channels in your game to generate sound, because usually in a game you want to have sounds that overlap on each other. But if you just use one channel, you can't have a sound that plays on top. So you want a game music, right? Game music, you want a background sound effects, right? You want to have another, and you might want to be running through a hall. So if you want like footstep sounds, like if you're doing footsteps, then that's would be another channel. And then you might add reverb to it because you're running down a hall or a tunnel, right? So that's how you do it. And Unity sound channels. Let's do it. Unity sound channels. I'm pretty sure. So it's been a while. Since I've done this coding, but I'm pretty sure Unity supports different sound channel configurations. I knew it. But the different support formats, channel types. Audio can be stereo or mono, sure, but up to 8 channels. Oh wow, that's amazing. Playback is important. Playback audio clip, which can be done in audio source. Okay, so you have to use audio sources in Unity, and in a game object. Okay, so audio clip, you can assign an audio clip to the audio source to play the sound in your scene. I think that sounds pretty straightforward. It's much easier to do in Unity. Back when I was doing DirectX sound and other kinds of hardware accelerated audio that worked on sound cards. Did you know that computers used to have dedicated hardware for sound? Now it just runs off your processor. No problem. No problem now. Isn't that crazy? I think it is. It's kind of crazy that you ordered food from Swiggy today. You did leave game. Guess what? Guess what? That is, yep, you got it. You got it. Check it out. Swiggy right here. Swiggy on the screen. Boom. If you ordered food on Swiggy, yep, you're using my technology. If you didn't know, that is really cool, isn't it? I think it's pretty cool. I think it's super cool. All right, so let's see what else we got here. What else we got on our chats here? It is kind of crazy. And PubNub probably also earned some cents. We did. We earned some pennies. You got it. Is C++ hard to learn? MC Channel. It is. Also, C++ was my very first programming language that I learned because I didn't know to learn anything else. I didn't know that there was another option. So I learned C++, and it was very challenging. Do not use that as your first learning language. Use Python. Python is going to be a lot easier for you to learn by a lot easier. And it already teaches you all the necessary foundational computer-like algorithms that you need to learn that spans every programming language. So there you go. You want flow control, iterations, variable assignment, expressions. You got it. Python's got it, and it makes it really easy to use. Mr. Blum, and back, Mr. Lamb. Hey, Mr. Lamb, welcome on back. We're doing some AI. We're trying to do some AI is what we're going to do. How many programming languages do you know? Tello. All right, let's see if we got them. Let's see if we can name all the programming languages. We got Python. We've got JavaScript. We've got Java, of course. We got Ruby. We got PHP. We got Erlang. We've got Rust, which is our best language. C, those language. We need to put those at the top. Of course, we also got SQL, which is the DSL, right? SQL. Let's just throw some DSL in there. HTML, CSS, of course. Those are DSLs. What else? I bet you. I don't know. Oh, Perl. Why didn't I forget Perl? Of course, Perl is a great one. Perl is awesome. All right, so there's some languages. I'm pretty sure I left some out. Have you? I have to go. But Code Cookie, you subscribed? Thank you. Would look forward to more fun scratch type bids. Excellent. That sounds good. Excellent. Bids, videos. Okay, cool. Sounds good. Hannah, is there anything else you could do in Python? You can do everything in Python. Python is the premier language. If you're going to learn computer science and you're going to learn AI or data science, Python is number one. It is number one when it comes to data science and number one when it comes to artificial intelligence and machine learning and deep learning, all those things. Python is used because of PyTorch. Facebook or Meta came out with PyTorch, which is the world's most prevalent open source framework for deep learning AI, which is what ChatGPT is written in. If you want to make your own ChatGPT, you use PyTorch Transformers. PyTorch Transformers is what you do. That's the answer. July Ord, hey, how's it going? Hello, Stephen. Guess what? We implemented the things that we wanted to do. Hello. Is this we're going to do tonight? We're trying to make the XOR NN, but I defined tan H as a derivative and spent 3 hours debugging correct code. You know what? That's where the problem was. You figured it out. I did. I spent a little bit of time. Don't go, Hannah. Don't go. Don't worry. We're still here. We are still here. Things are happening. Sir, Mr. Lamb, after you disapproved my cases. Oh, right. Cryptographic agility and mandating TLS 1.3, forward security plus robust PKI public key infrastructure, lifecycle management are foundational for protecting in-transit confidentiality. You got it. If you want some security, PKI is what we use. That's what the internet is basically based on from a security perspective with TLS. You have root certificates that define your trusted sources, right? PKI, public key infrastructure, that will bring you the place where all the public keys exist. And you can capture those public keys and then use them to encrypt data. And that is critical. So that way when you purchase something on the internet, no one sees your credit card number. And that's how that works. Can you make websites with coding? You totally can, Hannah. Absolutely can. We can totally do that. Make websites with coding. You got it. All right, so check this out. This is our original model here. You can see it's really simple. When you do forward propagation, you're basically just doing matrix multiplication. You're moving data forward through a bunch of matrices, and that's what that looks like here in this function. Really simple. You got your input data, which is your sentence, right? You got your hello, how are you? Your hello, how are you? Like your sentence data, you vectorize it. Maybe you embed it so that way you've got some semantic meaning with all your words. Then if you wanted to, you could apply self-attention and some positional encoding. If you only positional encoding if you intend to actually use the positional encoding. Most applications might not. You might not. Do suggest learning Rust? Yes, Awad. You got it, Awad, Mohammed. Rust is a premier language. Rust is huge because when you compare it to what we're doing, we're replacing all of our code with Rust. Every code is getting replaced with Rust in our company because it is super fast. It's super efficient. It's got concurrency safety at compile time. No other language really does that. No other language. You've probably heard of something like Java. It's like, oh, Java has memory safety and Java has concurrency safety. Not really the same thing. Those things are kind of built in at runtime, but you can still run into problems at runtime. Java has that problem, but Rust, it moves all those challenges to compile time. So you don't even get to release your app until you get it right the first time. So that solves around 70% of all bugs deployed in production. Isn't that crazy? And we're doing that now. And it's so good. It's amazing. So Rust is my answer. My real name is Yasin or Yasin. Yasin? Yasin. All right, Hannah. Your real name's Yasin. Happy you mentioned it. Anka Mora, how's it going? Welcome on in. Golang is faster. Tello. Oh, you actually, Golang and Java are about the same speed. So you've got Java and Golang. Don't get me wrong, they're very fast, very efficient languages. They're better than Python, for example, better than JavaScript by a lot. So Golang is faster than JavaScript, and it's about the same speed as Java. But if you're going to compare the fastest possible languages, Rust and C are way better because they're just as close as you can get to the best possible performance that you can get. Actually, I want to see this. Let's do that. All right. Rust versus C versus Golang. Performance chart. See if we can see it. Let's see if we can see it. Okay. See if I need a chart. I need some graphics. Where are we? Maybe we can go into some images here. Maybe we can look at images. Okay. Is this Rust versus Go? Okay. Is this good? I don't know if that's interesting enough. Maybe this. Anyway, I'm not really seeing anything that is helpful to describe, but yeah, Rust is going to be definitely faster than Golang because it's. Ooh, what about this one? Nope, not that one. Yeah, I'm not finding what I want. Oh, performance metrics. Okay, let's see if we can zoom in on this. Here we go. All right, zoom in. All right, here we go. We zoom in. Performance. Okay, Rust. Okay, so you can see this isn't also a number of requests per second in thousands. Okay. So yeah, I mean, it depends on the algorithm, but you can see even in this case, Rust is faster than Go. About the same speed. Also, memory utilization, Rust is better. You can see it uses less than half the amount of memory needed. Compile time for sure, yeah. Compile time, because it's got all the safety checks up front. Compile time, Rust is going to be a lot slower to compile, but it's worth it. It's worth it, you guys. It's worth it. It's absolutely worth it. Okay. Golang cannot be as fast as Rust because it has garbage collector. That's right. Then it is a programmer experience. You got it, July. You totally nailed it. Mr. Lamb. Wouldn't doing that first allow us to apply Apache flaws, or you say, I'm thinking Apache, with Metasploit, reverse TCP shell, and DNS queries? What are you talking about, Mr. Lamb? What are you talking about? But if you have there, don't worry. There's still ways. There's still exploits that can get around. You cannot hide completely on the internet. You cannot completely hide. So, Mr. Lamb, but some of the things that you're describing, yes, they do reveal more information. It's true. We've got Hunting King. How's it going, Hunting King? It's all JavaScript, whether you want it or not. It is. You're right. The entire internet. JavaScript is the number one language. It is the most prevalent language in the world because the internet. That's the answer, because the internet. all the software as a service companies, all your web server Node.js apps, all your websites, right? They're huge. Billions of users are using these things right now. It is the world's largest, most utilized language. JavaScript is the answer. Do you know anything about Roblox Studios? It's very easy to make games. Roblox, yes. Roblox is actually kind of a neat ecosystem, because if you compare it to Minecraft, sure, there's mods and a mod framework in Minecraft, but Roblox is different. Roblox is intended for you to design your own sort of game experience within their virtual world. So it's really neat. It's kind of a neat alternative approach to thinking about how games should be deployed to humans. Mr. Unknown, hey, how's it going, Mr. Unknown? Bro, say something about the future of Java. Oh, yeah. Well, the JVM is still around. But you're not necessarily going to use Java. Java is kind of more of an academic language now. Java is an academic language. It helps you kind of understand some of the logic around maybe threading. I'd say it goes pretty good threading, object-oriented programming. It helps you from an educational perspective. But when you go into industry, you won't necessarily be using Java ever. You'll never be using Java. Are you going to be building a mobile app on Android? You're going to use Kotlin. You're not going to use Java. You're going to use Kotlin. Are you going to be building some server apps? You'll probably be using Node.js or Python or, Rust, maybe even C. Probably not C anymore. Rust is going to be the answer if you're going to be doing something like that. But Java is no longer premier. It is educational purposes only. That is the future of Java, and that is the continuing trend. Did I miss something? Are you making a sequential neural network to predict words? Oh, we can. We just went into multiple conversations. So we were talking, how do the large language models work? They tokenize, which converts them into, and then they embed them, right? You get an embedding, which just basically means a very big array of numbers that has a semantic meaning about the word. And then you self-attend by multiplying all the words with every other word. And then you add positional encoding. So that way, as you're feeding tokens in, you can continually append a token, and the positions will be updated in a way that allows it to understand that things are kind of moving forward in a sequential pattern. But basically, this is just the vision of the AI. What are you letting the AI see? How is it going to perceive the world? And then you have filters similar to convolutional neural networks, Q, K, and V layers, that then you pass this through, and then you get a final output on this end over here, a final output, and then you softmax it, and then you don't have to. You just need to get the biggest number, but you also in the middle here, in the middle layer is going to be your deep layers, right? You got your deep layers. Things like that. So, which are just more matrices. It's all matrices, everyone. Don't worry, the whole thing is just a bunch of numbers. It's a whole bunch of numbers, you guys. Mr. Unknown, what should one choose? Python, Java for next? Python. There you go. For the next 5 to 6 years, Python. Only do Python. Java, not necessary. Not necessary anymore. Python, way better. It is premier language for artificial intelligence and premier language for data science. And premier language as well, not as much maybe as compared to JavaScript, but you can also use it for server-side tech as well, and for scripting. Hana, excellent. Some games have copyright music. Yes, indeed. You're totally right. Tom Collins, how's it going? What do you think about PHP? Ooh, Tom Collins, PHP. It's one of the first server web languages that I learned. I learned Perl and PHP back in the day. And it still is very prevalent. WordPress is PHP, right? WordPress is all PHP, you guys. The language has been improved a lot lately, especially with Laravel. Laravel is an excellent community and an excellent major framework. Yes, PHP, still very prevalent on the internet, is one of the largest frameworks from a web server perspective. PHP is excellent. So it is huge from a web server perspective. That's all it's used for. It's for website. It's got a specific purpose. Mr. Lamb, what do you got? Also, sir, if it's not too personal, okay, we'll find out. Want to know? We'll see. What is the valuation? Oh, valuation of Pubnum. There is, I can't. It's private. That's definitely private information for shareholders' purposes. Audited, not self-generated, and also, what's your net worth? Oh, dude, only if you're comfortable with sharing. Say we're comfortable. Let's say that we're comfortable and very happy, and we're doing very good. We're doing very good. When I am saying very good, I'm very good. Let's just say very good. We can't give you here. Actually, Mr. Lamb, check it out. I'm actually going to be really excited. We'll have some information for you in the coming years. Let's just put it that way. In the coming years, there's going to be a really exciting stream. And I'm going to be able to tell you all the questions you ever wanted to know. I'll be able to tell you all the questions, but right now we can't. We've got to keep it secret for now. But stay tuned in years to come. Stay tuned in years to come. There'll be some exciting announcements, you guys. Some exciting announcements in years to come. So don't go away. Well, I mean, definitely come back in a few years at least. but still hang out meanwhile. We're going to hang out meanwhile, right? There's no reason to leave for now. But you can't make Minecraft plugins and mods with Python. Oh, that's a good point. Yeah, actually, I'm not sure. I think Minecraft is Java, right? Don't you build I believe Java in Minecraft plugins, right? I think so. I'm pretty sure it's Java. Thank you for your likes, you guys. Hunting King. Also Whimsy Tunes TV. Hey, how's it going? Welcome on in. Happy to have you here. Hunting King, what do you say? I've only made one real project. We got to make another one. You got to make project number 2. I only was making it with my father, so I had to comply with his methods. And use PHP and vanilla JavaScript. And he still can't read my code. No Laravel, no GitHub. Hey, Hunting King, you got to start somewhere. Actually, it's really good to get your type on the keyboard and see what comes out. Then now you can start on your own. You can build. You can go off into the adventure. You can go off into the adventure and find a new world. Find a new world all your own. It'll be really great. You can build any project you want next. Actually, Hunting King, what do you want to build next? What do you want to build next? I'm actually kind of curious. Hannah, you haven't talked about horror games. Like there's a lot of scary horror games that are like there's survival horror games, right? You've got your Silent Hill, you got your Resident Evil, but there's also, Phasmophobia, right? Like there's some other really fun multiplayer games that are scary, but they exist. I tend towards like a Minecraft myself, like a Minecraft or a strategy game. I like those. Those are great. Yeah, Minecraft plugins or Java or Kotlin. Tello, I didn't even know you could do Kotlin with Minecraft. That's really cool. All right, you guys, here we go. Let's go through it. All right, so we've got here our deep learning model. Epochs is the number of times that you're going to train your data on your data set. So this is one epoch worth of data right here. You're looking at one epoch. So this is an XOR operator. And then we've got our sigmoid activation functions, which just tells you that you want to keep your numbers between 0 and 1. You don't want your numbers to get too big or too small because you've got vanishing gradient or exploding gradient problem, which basically just means your matrix have numbers that get really too big. All right, let's do this. Vanishing gradient looks like this. So you got, let's just say you've got a whole bunch of numbers here. And then you've got some bigger numbers, right? So you got some bigger numbers, 1, 1, 1, 1. And you don't want the numbers to get too close to 0. Like this is a gradient that is vanishing right here. And really, it looks more like this, like really big, small numbers. It looks like this, a whole bunch of really big, small numbers like that. That's a vanishing gradient problem because you can't get out of the hole after a while. Because if you try to multiply a number like this to do learning on it, to learn on this data, you'll have a hard time to get out of this hole. And so it creates these dark spots or hot spots if your numbers get too big, which prevent you from getting generalized knowledge. So you got your vanishing gradient or your exploding gradient. Exploding gradient, which is big. You know, we're all talking about numbers. You're all numbers here, you guys. All numbers. Wait, hold on, Mr. Lamb. Why would PubNub valuation only be reserved for equity shareholders? It's not public. You're right, because it's private. You got it. It's private. If it's public, then you'd be able to easily see what the market cap is in the case, because you just look at the total outstanding shares and the price per share. Boom, you got it. That's the valuation, right? Isn't it something simple like that? It's really simple. So that's when you get the public information on it. But yeah, some companies that are private, they do share that information. But at least for now, our goal is to do some amazing things. We're going to do some amazing things. In that case, the balance sheet and appropriation would be published in the website. You're right. If it was public, If it was public, we would have to file an S1 and we'd have to show all our balance sheets and P&L, right? All of it. We've got to show all of it. Hannah, how do you make your character run? Oh, you can hold like shift. You have shift, right? So we were talking about that earlier. Do we have it? Do we have it here still? So then you can have keycode.shift, right? So like this, check this out. Maybe like you could do shift. Let's see, input.key down. Let's see if we can go into, oh, wow, it's giving us a lot of information here. Let's go into deeper dive. How about shift? How about shift key? Here we go. The shift key. And so you'll just, it's the same. Shift key plus W, basically, is what you want to do. Shift key plus W. Hannah, that's the answer. Hunting King, I've been trying to make my own programming language for like 3 to 4 years, but just stop and make everything from scratch every time. Hunting King, oh, wow. There you go. So, yeah, so here you go. Keycode.left shift and keycode.right shift. That's how you do it, Hannah. That's how you do it. You just have an if statement and you can see, and then you can have your character start running here. Oh, make the player run. Look at right there. Look at this. What do you know? Make the player run. We know things, don't we? Listen to this. Isn't it neat? Isn't it neat? There you go. Make the player run. That's the way to do it. There you go. We know game development. I wanted to be a game developer before all of this in computer science and computer engineering. That was the thing I wanted to do. But I found out that industry and enterprise is more interesting. I'm beginning from a profitability perspective. How do you publish names? Wait, what do you mean? What do you mean, Hannah? Actually, not sure. But Hunting King, are you building? When you're saying you're building your own language, are you compiling to assembly? So you have your high level language and you're compiling down to assembly. I'm kind of curious. What architecture are you using? How do you publish games? How do you publish them? Got it. How do you publish the game? So you can go to a publisher, or you can release your game as a self-published on Steam, right? On Steam. So you can publish a game on Steam, right? Publish game on Steam. How can I get my game on Steam? Here you go. Here you go. Steam Direct. This is it. How do you get your game on Steam? Just follow these instructions. So you make a game, you get it in Unity, and then you put it on Steam. You have to follow all the rules. And then, there you go. This fee is non-refundable. Wait, there's a fee. In order to get fully set up, you will need to pay a $100 fee for each product you wish to distribute on Steam. So there's an entry fee. But guess what? That's how you do it. This is how you do it right here. Publish your game on Steam. There you go. July, we're going to use this framework to make something other than memorize XOR? Yes, July, help me. July, I need your help. What could we do with it? July, help me. Let's figure it out. July, I need your help. What should we do? What should we do other than XOR? Here, all right. So we were going to go through, let's see. So we kind of went through the code here for the most part, just to show everyone. So you've got forward propagation, you've got your back propagation, and then you've got your optimization, the part where the AI learns. So this is the learning segment. And this is where, if you don't want the AI to learn, you don't need any of that. You can get rid of that there, like that. Boom. You don't need that. You don't need this code here. This code is not necessary. If you just want the AI to use the existing AI that's been pre-trained, this is all you need, just the forward part. You don't need anything else. You don't need any of the other things. All right, here, 1 second. July, I need your help to figure out what can we do. What can we do? What can we show? Wait, codes. Shoving codes. Which types of projects should we take up in sophomore in college? AI. If you can, Python and AI, or Python and data science, or some sort of data science project. That'll be great. If you have a chance to do that, I think this would be the greatest. I think that would be the greatest. All right, let's see if we can comment some of this out here. S// and then go like this. There we go. Get that commented out. All right, let's see if that case there. And let's close this off here. Let's get rid of that. All right, let's see. Let's double check. Python ml-og. Okay. Yes, looks good to me. Looks good. Okay. So the OG still works, but let's bring that back in real quick. Let's bring that back in. I want to get rid of the epoch number. Epoch. Where's that? Here we go. All right, here we go. Let's get rid of that. There we go. Boom. Okay. So there's the OG, but by ml.py, we updated it to made it a little bit better. It's a little more hard to read, but I think it's just a slight smidgen better. What's your thoughts on Go? Golang and its use case? It's great for web server applications. It's been specifically built with batteries included for web server development. If you're building an API on the web, Golang is actually really great. It has it's not great for like massive ultimate scale. You'll want to use Rust or C for that if you're doing gigascale. But if you're building just a common like API that you want to release on the web, Golang is a really great language. It's intended for building APIs. That's what Golang is for. It's its best use case because it already has all the web server components built in, and you don't need to import external dependencies. It's all built into the standard library for building web server applications. There you go, HTTP APIs, you guys. If you code, it's not going to be 100% close to real life. Correct. Wait, what do you mean? What do you mean, Hannah? Yeah, it's all digital, so it's a representation of reality, and it's only just like a fraction of it. So yeah, I think it'll be like a very small amount. Hey, Mohammed, what's going? Hey, welcome on in. Welcome on in, Mohammed. Dogen. Sometimes C++ is easier than Python. It's truly what I'm thinking. It really depends. So C++ is a premier language for AAA games and Unreal Engine, right? C++ is fantastic. It's built for AAA games, for performance and speed, because games have the highest demand on hardware, right? Games require the most out of a computer. Your GPU, your CPU, the audio, all of it, you're sort of generating a world, a fantasy world, and you have to render as many frames as you possibly can per second while also being engaging. It is one of the most challenging things in computers, is building a game. So if you want to challenge yourself, build a game. That would actually be a really good next project. So if you're talking about next projects, building a game is 3,000 epochs. What GPU are you using? Oh, Mohammed, don't worry. This is a CPU. We can more than easily, because this is 100% of the data right here. This is 100% of the data. All right, so check it out. Let's do this. Let's run this. Let's run it over here. All right, Python ml.py. Here we go. Wasn't that fast? Look, and we got 100% accuracy. 100% accuracy. And from July, thanks to July, we added our sigmoid from the output layer, our sigmoid derivative, and we added it right here as the last layer. So right here, we've got the sigmoid activation. Sigmoid activation right here, which is the output layer, because it's always going to be between 0 and 1. Between 0 and 1, you guys, and so you want your output layer to match what it's going to be in your intended binary classification is what we got here. So it's a number between 0 and 1. Is AI going to take over coding? It already has, Hungry Kitty. Hungry Kitty, it's already taken over coding. You no longer have to write code. The AI will write it for you, but we still need engineers. We still need you. We still need humans. Humans have ambition. They have drive. They're motivated. They have objectives. They have intentions in life. And we need engineers, because engineers will actually, take something forward with an ambition. These AIs that exist today, they're just machines. They're just like algorithms that help you generate codes with a giant paintbrush. So you no longer have to type code by hand anymore, although it's still fun. It's like a fun exercise. I would still recommend doing it because it makes it easier to learn. You still want to, it's like writing down. It helps you learn. It just helps you learn, you guys. It's always been true. Behavioral analytics and machine learning anomaly detection can surface novel tradecraft that signature-based approaches miss, but they need quality baseline telemetry to avoid false positives. Pretty much. I don't know what to say about that. That was like a really accurate and very focused statement, Mr. Lamb. It was a very focused statement. You do need a lot of data. You need to focus. Lost YouTube. Hey, can we meet? I said, hi, how's it going? Sure. Absolutely, Lost YouTube. Join us on Discord. Lost. And then we can DM, and then we can even chat on Discord. You got it. Happy to do it, Hunting King. I'm more like designing it. Oh, you are? Okay, so you're designing your own language. Though I can use LLVM. Okay, cool, of course. Okay, so using LLVM as the compiler to the assembly. LLVM to compile to assembly, and then you've got assembler to machine code, and then you've got your linker to link into the operating system of your choice that you're targeting. You made so you can put hard code print statements into an object file. Oh, really? But since then, I've been rewriting over and over. Hunting King, this actually sounds really cool. Would actually like to check it out someday. Some games take months to make. Hana, gonna tell you something. Most games take months to make, if not years. Hana, most games take months to make, if not years. Are kind of for Windows kernel drivers. Wait, AIs? Oh, are they? They're not great for Windows kernel drivers. Oh, you're talking about the AI code generators. The AI code generators, they're not as good. So Tello, they're getting better. I can tell you, they are getting better. You're right. They're not perfect, but they are getting better. But Windows kernel drivers, I'm not so sure about, but at least for low-level programming, they're pretty good. Have you ever competed at Kaggle? I've not competed at Kaggle, but now, after many years, I feel like I probably could at least be in the leaderboard. I could at least be in the leaderboard. XYT said, hi, how's it going? Happy to see you. Radiant Energy. How do I find your Vim code config? Oh, you want to see the Vim config? Okay, we got it here. I got you. We'll put this into our Discord. Let's do it. Let's do this. All right. vi./.vimrc. Here we go. There you go. Vim config right here. There we go. We'll put it into Discord. Here we go. It's on our Discord channel. 1, 2, 3. Vim paste. 1, 2, 3. There we go. Done. Vim right there in Discord. There it is. There you guys go. Oh, and if you want to join the Discord, let me paste the link here for you guys. Let me copy that. Thanks. Happy to help. Happy to help. There we go. Paste it into Discord. Happy to help. There we go. Wave. Hey, we got Discord people. All right. Welcome on in, you guys. Welcome on into the Discord. Here we go. We got your Vim RC file. Boom. All right. Here we go. Do you know Bcart? I don't. Who's Bcart? Do you know who Bcart? I don't know who Bcart is. Radiant Energy. I don't have Discord. Oh, no. GitHub? Okay, Radiant Energy. Just for you. Just for you. We'll do it. All right. So gist.github.com. Let's see here. Let's make a new one. We'll paste it in. We'll do, oh wait, that's the wrong, we gotta repaste it. We gotta repaste it. Where is it? Copy and paste that. Here we go. And then we will also, this here, we'll do Vim, Stevens, Vim RC file. Then this will be like .vimrc. There we go. There we go, you guys. Create a public gist. All right. Public gist. Perfect. Public gist. I'll paste that over here for you. Radiant Energy. Here you go. Here you go, Radiant Energy. Just for you. Just for you, Radiant Energy. There you go. Happy to help. Happy to help. All right, let's get back to some of our code here. There we go. And close that. We don't need that anymore. There we go. Bringing that back over there. All right, Mohammed. People still think programming and coding both are the same. Oh, they're different. You're totally right. Yeah, you've got engineering, which is architecting and designing, a thought process that requires you to really think about how systems are going to communicate and interact and how you're going to build algorithms that perform well. And coding, which is just typing on the keyboard. Typing on the keyboard to realize your ambitions as a software engineer. You spend 90% of your time thinking, designing, architecting, and then implementing algorithms in your head before you even start to get to coding. And then you spend 10% of your time actually typing on the keyboard. But now that we have these large language models, you can save 10% of your time, and now it goes to the LLMs. You still need engineers, though. You still need to be thinking. Programming versus coding, different things, you guys. To replace programmer, we need AGI. You got it. We need artificial general intelligence. We still need humans right now. With this, generative LLMs can only speed up coding. You got it. But not replace programming completely. Absolutely. You got it. You were totally right on that perspective, Mohammed. You got it. Mr. Lamb, the AI wrecked the code chess components, would be a lot easier than AAA, like Stockfish. Yes, if you build, it's much easier to build simple games by far. Building simple games, you got it. It's free, Hana, absolutely. I wrote my own GPT daemon that codes basic locally. Oh, really? That's really cool. I built a prompt generator plus a repo meta builder that describes the repo, and the agent can move freely through the repo and make code changes. Charles W., that's really cool. Not a lot of people know how to do that yet. Not a lot of people know how to do that. You need deterministic output from the LLM. In order to achieve deterministic output from the LLM, what you can do for deterministic output, you need something called function calling. function calling. Like you can even do OpenAI like this. Function calling OpenAI. Like that, you guys. OpenAI like that. 1 second. 1 second. There we go. OpenAI function calling. And you can do this in other kinds of fashions, but it gives you deterministic output. So you specify what you want the output to look like, and then you can have the AI provide you exactly the output you're looking for. Exactly the output you're looking for. Then you can build an agent that's a coding agent, and it can do anything you want. Or a vision agent that can drive a computer or drive a car. A whole bunch of things. A whole bunch of cool things. Eddie Legendary, how's it going? What is this? Hazal Patel, thanks. Happy to help. Radiant Energy, happy to help. Let's see here. Trying to get some more to the chat messages here. This is where I'm going on the chat messages right here. I'm reading your chat messages, you guys. Is CompTIA still worth acquiring, or is it outdated in 2025, going in 2026? What is CompTIA? Hold on. What is CompTIA? I don't know. Let's find out really quick. CompTIA. What is that? CompTIA. AI for everyone. It looks like it probably is fine. It looks like it's fine. It's embark on your journey for the world of artificial intelligence with CompTIA AI Essentials. I still recommend using YouTube to learn on YouTube. Recommend YouTube. It helps you learn a lot, and it's free. It's free, you guys. Learn on YouTube. But this does look like it requires you have to pay money for this, and I don't think you should pay. I mean, it is $99, but I don't know. I mean, it's not going to make you. It looks tempting. Don't get me wrong. It looks tempting. Be careful with temptation, you guys. Be careful with temptation. Just be careful. That's all I'm going to say about that. But you could, if you want, and it can help you still. But yeah, it can help you. But the algorithms for AI, they're pretty foundational. They haven't really changed a whole lot. There's been a little bit of innovation, but not for the past 5 years-ish. We're basically just leveraging the best we can from existing algorithms. And that's where you get like Sora and ChatGPT and Claude Code and Gemini and Nano Banana, right? All these things, these are algorithms that we're just actually implementing in real-world applications that are useful now. Real-world applications that were useful for now. You kind of do test-driven development. Yes, Charles, test-driven TDD, you got it. TDD, excellent. Actually, so the agent can, oh, wow. Really? So the agent can validate its own changes? That's cool. No way. That is a really smart idea, Charles. Okay, so you design. This is a really cool workflow you've designed. So you, as a software engineer, you do TDD, test-driven development, and then your AI fills in all the gaps. That's really smart. So the agent can validate its own changes. Otherwise, you look over its shoulder all the time. It gets caught in logic loops, and often otherwise it will fail. You're right, Charles. You're smart. That's a really good idea. Do test-driven development. That's a great way to interact with these AIs. You guys, you're amazing. I'm learning all these new cool things. Charles, that's brilliant. Brilliant, Charles. Eddie Legendary. I can only be here for like 3 minutes. Oh no, Eddie Legendary. That's no worries. All good. We're live every day of the week. Every day of the week. That is Monday through Friday. Dojo, what are we cooking? Dojo, we're cooking. We got our AI here. July was supposed to help us figure out something that's better than XOR operator, but check it out. Here's the answer. So we did it. So we trained an AI model to learn the XOR operator. The XOR operator. We could also have it, we could train it on like the AND operator. I would actually like to try that. I wonder if, would that work? Do you think that guys would work? I'm not sure. But Dojo, that's what we're doing. So we went through the AI model that we have here, a really simple AI model in 100 lines of code. It's a deep learning model. It's actually kind of cool. I think it's kind of cool. How low can we go? Can we go lower on this? I'm kind of curious. I bet you we could. I bet you we can make this more efficient. Can we go lower? Let's try it. Let's try it really quick. Yes, no, it's too low. Oh no, we're good. But it is a little bit too low. We're seeing some, there we go. But we're doing good. We got results. True. You want to see true all across the board. We're looking good, you guys. Stephen, it's so true. Development used to take a lot of thought processes compared to today's thinking, thanks to AI. You got it. It's just we still have a lot to think about, but the AI can fill in the gaps for us. That's what it's doing. It sees patterns and it can repeat the patterns, but it doesn't necessarily know any patterns that it hasn't seen before. It doesn't necessarily know. It doesn't know for sure, but it can still be creative. Just looked at the title of the stream. If you pull tan H off. Wait, what do you mean? What do you mean TAHT? That's sick, dude. Wait, Eddie Legendary? Thank you. That's a really good compliment. But we did it. We actually did it. Yeah. So this is from scratch, completely from scratch. We did it all live on stream. Our own machine deep learning framework. And it's only 100 lines of code. Actually, it's less than that. We're actually using it as about, here's the usage of it right here on the screen. So you can see here, that's how you use the framework. You just define layers and then you train the model. And then here's our actual deep learning model right here, which is really clean. It's really clean. And it's rare because a lot of the AI code that you see out there today, it will be, thank you for the likes, you guys. It'll be verbose. Here, check this out. Check this out. Look at the verbosity. This is a for instance. Thank you for the likes, you guys. This is for instance. This code right here isn't even deep learning code. And it is a touch more complicated. It's a touch more complicated, don't you think? I would say it's a touch more complicated, and it's about the same length. It's about the same length, and it's just a little bit more complex and harder to follow. It's a little more harder to follow. So I made it so it's easy to follow, right? Really simple. And you can see here that our methods, just a few methods, basically encapsulate all of the required functions. Right there, you got it. Wow, Charles, that's an awesome idea. It is. Charles, good idea. Okay, need to go now. Okay, Eddie Legendary, sorry I missed your message earlier. Hope you have a good day. Mr. Lamb, sir, would using connection and SynFlood, SynFlood, you're talking about TCP now, hardening the OS, TCP sync cookies, net filter, rate limits, prevent attacks from scammers? No. That does not prevent, Mr. Lamb, that doesn't prevent anything. It does prevent some sort of a DDoS attack, because you can do a SynFlood on the kernel level, which basically requires it to send back data to your device or the responding IP address. And so you could attack, that's an attack vector. And then you can do things that hurt the server using that. But you can't do a whole lot from a scamming perspective on that. All you can do is just slow down or halt the capability of the server. That's what you can do there with SynFlooding. That's what you can do with SynFlooding. Wait. July, I missed your message. I thought, I don't know how, could be the implementation, but what do you think about a melody generator? Like predict the next note and duration? Now you're talking music. Right? Now you're talking music. July, that would be so cool. We need a lot of data for that. We need a lot of data. I suppose we could generate a whole bunch of toy data, but we won't necessarily know if it's working. We won't know if it's working, but we totally could, because we could use full self-attention to generate it, and then we can use we could do a positional encoding based on the melody that we're looking for. And the input tokens are super easy because it would just be a tone value, right? A frequency or a wave. And then we just need to construct it into sort of a condensed vectorized version so the model can learn on it. And then we can have output that sort of inflates the data at the end of the at the output layer. It takes the actual note that it's trying to achieve and then string it out so it makes a sound on your audio. We could totally build that. 100% we could build that. Here's a good idea, July. Thank you. Thank you. Really good, July. All right, so I'm trying to catch up on some of the chat messages here. Sorry, guys. What are servers in gaming? So if you want to build a multiplayer game, you have a server, which is a secure code execution environment that allows players to join together. And that's also what we do. That's what we do at my company, PubNub. So PubNub will allow you to play. We've got a Unity SDK. We've got a Unity SDK. So if you want to build multiplayer games, you can use our Unity SDK, and it's got the server aspect. So it makes it really easy for you to build games in multiplayer. So you just go to our SDK section here. Let's go to our developers, SDKs, and then I believe you just click on Unity. Here you go. And now you can follow the instructions, and you can build your own multiplayer game and release it on Steam. And you don't even have to, own your own servers. You just use our API, and that's how you do it. That's how you do that. All right, let's see if I can get some more chat messages here. Super Tim. Hey, how's it going? happy to have you in here. Yeah, Tom, I gave GPT make daemon for you that can do create, read, update, delete within a specified directory. Then issue its prompts to dev for you. That's cool. That's actually, so you gave it the ability to do that. That's really smart. So you figured it out. Not everyone can figure that out. That's really cool. Let's go. Steven is cooking. July, that would be so cool if we could build something like that. We'll have to do that at some point. I think that would be really fun. I think that would be a really good one. I would think it's a really good one. The base agent, okay, Charles, the base agent can also duplicate itself. Oh, really? So you can spin off like a thread, basically. It typically runs 4 bots: a developer, code reviewer, manager, and an overall guidance bot that validates everyone is working towards high-level goals. Charles, that's clever. Good job. Mega Animations, how's it going? Man, machine learning is the future. You got it. Machine learning is the future. We're there. PubNub, you own it. Yes, Mega Animations, you got it. That's it. We own it. We own it, you guys. Great. Would try doing that. Tom Collins, what Charles is describing is pretty smart, I think. We have a stepped into. Wait, what have you stepped into? Callum, how's it going? Callum Finlayson. Callum Finlayson. How's it going? What have you stepped into? Artificial intelligence. Yulvis. Cool. Hey, how's it going, Yulvis? Mr. Lamb, Mega Animations, I searched him up. He's a CTO and I think co-founder with some Tom guy. Yeah, Todd. His name is Todd, you guys. His name is Todd. Let's see. Yep, there you go. Todd. His name is Todd. With some Tom guy. That's funny. His name is Todd. Super team. What are you making today? So we are just reviewing the final outcome over the last few streams by making Super Tim. We made our own machine learning model from scratch, right? Using NumPy as the only dependency to make it nice and easy. And now we're going to play with it. Now we're just going to have fun. We're just going to have fun with it. And you can see here on the screen. Here's the output. So you can see the model, it learned. It got the answers correct, you guys. It figured it out. Isn't that cool? I think it's beautiful. I think it's just wonderful. I love it so much. Oh, you know what? Wait, hold on. Oh, wait, did I? Oh, look at that. I moved my window. Oh, I shouldn't have done that. Oh, I moved the window. Oh, it had pixel precision. All right, let's see if I can fix this. It had pixel precision. I moved it. That is so crazy. Okay. It was so crazy. Okay, so now we can see it a little bit better, although the Python logo is kind of getting in the way. But that doesn't matter because, don't worry, nothing to see there, nothing to see. We're all good to go here. Let's see, can I move it down? Can you go? No, okay. All right. Python ML, there we go. Okay, so what do we want to do here? Nice, Super Tim. I know. Man, I need to really lock in on AI and ML. What are you recommending? Mega Animations. I recommend, at least to get started, Keras MNIST is a good getting started guide. So this is this the best one? That might be an old one. There might be a new one. Here we go. This one. This is the one. I think it's got 2025 in it. Yeah, okay. So here is a good getting started example with AI and machine learning. It's got MNIST, which is basically handwritten numbers. It's a data set of a whole bunch of handwritten numbers. And you can train the AI. You can train the AI on those numbers. Let's look at images. Here we go. So MNIST looks like this. So you've got these numbers here on screen. See the numbers? Let's see if you zoom in. These are handwritten numbers. And what you do is you feed this into your model, your AI model, and you can train the model to predict what the actual handwritten number is. Because 8s don't always look like that, right? And 7s maybe look a little bit different every now and then. But they have some similarities. Like look at all the ones. See, one looks like this, but one looks like this, but one could look like this. And so you train the AI model to learn what those look like. And that's a really good starting point. I think that's a really fun one. So this is a good starting point. It's kind of the hello world for AI is the MNIST data set. It's kind of the hello world. I like the XOR a little bit better because you can have all the data right here and it's really simple. You can also see the data. It helps you understand it a little bit better too. And this 100% of the data can be easily visualized in your terminal window. That's why I like the XOR operator. That's why I like it. Let's see. It really comes down to the prompt, quality, and the meta repo engine that describes each file. The reference to each other file is so it can traverse, and then hash each file to know if it's been changed. Oh, that's a smart idea. So then you know to change it or to reread it. That's smart. That's smart, Charles. This tells me that you really built the system. You really built it. You actually built it. You've made a coding agent. It's beautiful. Let's see here. Joshua. Hey, Joshua, how's it going? You look like the starburst that mildly melted in my pocket too. Really? Okay, Joshua, thank you. Mega animations. Wow, you got it. Okay, here we go. All right, so I actually want to try something. I want to try something. Let's make this into the AND operator. Okay, so we've got the same input data, but let's turn this into the AND operator. So 0, 0 is going to be 0. 0, 1 is 0. 0, 0 is 0, but 0, 1 is 1. All right, let's see if we can figure this out. So this is the AND operator. So this will be, AND operator. Perfect. Okay, here we go. Yes. Hannah, hey, how's it going? Yo, Hannah. Good to see you again. We're hanging out today. Saw you a little bit earlier in the stream. You're saying hi again. Okay, here we go. Let's see here. What is it? Can it learn? It did. It did. Look at that. Do you see what we did there? See, now you've got the picture, you guys. Now you've got the picture. Isn't it getting more clear? Sure 7B, you got it. This is a Sure. It's got the built-in, what do you call it? The thing. It's got the built-in thing, the boomstick. What do you call it? Yes, Shure 7. You got it, Genuine Profile. You got it, Genuine. It's got a built-in preamp. That's what it is. It's got the built-in preamp, which is like what you call those, like the cloud filter thing or the dynamite stick, but it's built into this one. I got it built in because it has a higher decibel amplifier, a preamp. There you go. Hey, Gavard. Coverrod. Hey, Coverrod, how's it going? Hannah, do you know what's Geometry Dash? Wait, that sounds like a game. Is that a game? Geometry Dash? I'm guessing. Geometry Dash. It's a game, right? Here we go. Geometry Dash. This would be a great game. So see how the style of game is right here? You could easily, where you got the jumping square, right? You've got the square that's moving across the screen. You got to jump. That's actually a really good game style. You could definitely build a game like that and then release it on Steam. Genuine Profile, nice. Yeah, exactly. Good microphone. Good microphone. I like it. Okay, so we taught the AI. Can we teach the AI the OR operator? Let's do it. Let's see. This is the OR operator. So let's see if we can do OR operator. Let's see if we can do it. All right. The AI is going to paint it for us. There we go. So can we teach it the OR operation? Is it going to learn? Is it going to learn the OR operation? We're going to find out. I'm actually kind of curious. I know, I'm pretty sure it'll work, but yeah, it's still exciting. Developing deep neural network from scratch. What's the task? You got it, Kavarad. That's what we did. We built it from scratch. And it's only about 100 lines of code. Here it is. Here's the major parts right here on screen. Let me close that window. So you see right here, this is the critical aspects. Isn't it clean? Isn't it clean? You look at it, it's only a few lines of code for each function. It's just a few lines of code, like 2 to 3 lines of code per function. And these are the critical premier functions, which is basically the current state of the art when it comes to building artificial neural networks, right? Or basically machine learning models or AI models, right? Right here, this is it. And I simplified it. I made it look simple because otherwise it looks like this. And it's kind of hard to follow. And a lot of tutorials will look like this. When you're building it from scratch, it looks like this. There's a lot going on here. What does this even mean? I think this is a little bit simpler to read when it looks like that. Hey, Akash. Hey, I joined pretty late today. Hey, no worries. We've only been live for about an hour and 17 minutes so far. What changes made to the neural network accuracy except increasing epochs and decreasing learning rate? Hey, Akash, you got it. Okay, so guess what? It was a typo. I made a typo. Here's the answer. I'll show you where the typo was. It was right here. It's really simple. It was right here on this line. Guess what it was? Check this out. All right, so it was 1 letter difference. It was this versus this. Do you see here on the screen? I accidentally deleted the H. I deleted the H by accident. Whoops. And that's what so you were here last time, right? Last stream. I'm like, what was the error? What made it broke? Because we broke it. We're like, oh no, it's not working anymore. What happened? That is because I accidentally pressed the letter X on the keyboard. Whoopsie doodles. Whoops. And so that's what happened. And so here you go. So this is what it looks like when it runs successfully, right? And there goes. See, look, we trained it on the OR operator, the XOR operator, the OR operator, and the AND operator. It all works, but it won't work if we press the X button right here accidentally. Look at this. Here, it's going to fail. See, it didn't work. It failed. It's got errors. And as you can see, it's run into problems. It's not able to learn anymore. It can't learn. So it hits a problem. It hits a problem. And see, it's no longer accurate anymore. So you've got this false here because it's not correct. It got the data wrong. And see how it's just broken. It can't converge. It's lost its ability to converge. Isn't that crazy? One single letter is all it takes to destroy the algorithm. Isn't that crazy? All right, let's put it back. Let's put it back, you guys. Now it works. True across the board. Right here, true across the board, right there on screen. Look at that. That is a good output. That's what we're looking for. We're looking for that output right there on screen. The good output right there. All right, let's see. Let's get so that's all we did. It was just one letter off. Sorry, Akash. Mega animations. Okay, man. All right, let's see here. Let's get back to some of the chat messages. Man, can you start creating detailed guides and concepts for machine learning? Might be a good boost for visibility for you. Make video tutorial style. I love your communication style. Absolutely, mega animations. So I've definitely built some videos on it. I've done deep learning. I've done building from scratch. I've done which is similar to what we've done over the past few streams, and a few others. So AI is one of the more common videos that I make because it's the most fascinating, I think, is artificial intelligence. Charles, wait, hold on, come on. Go with just Kava, the Java with K. Wait, but with K, Kava. Wait, is that a language? Thank you for the likes, you guys. Wait, Kava. Wait, is that actually Java versus Kava? Wait, is that a thing? Java versus Kava. Is that a thing? I don't think that is. It's not. It's not a thing. What are you talking about? Wait, Java widely used general purpose learning, while Kava, spelled Kava, can refer to a system for adding behavior reflections into Java bytecode manipulation. Oh, so it is kind of a thing. Kava as a reflective Java system. Okay. Or a plant-based beverage. It could be a beverage as well. It could be a beverage. There you go. It could be a beverage, you guys. Let's see here. No, Kava. No, wait, that's not what you're talking about. All right, let me know. Charles. So Stephen, imagine this local bot system plus, given a sufficient privileges in cloud via CLI, can have an automated deployments, and you can literally automate the actual engineer. We're closer than not, Charles. We're getting close, aren't we, Charles? You can automate all the things. What we need to do next is have a fully automated operation system completely running by AI. Something goes wrong, it can make some adjustments in the network. Something goes wrong, it needs to notify a human maybe if it knows it can't do something. But otherwise, you can automate all the deployment, all the orchestration. You can do it all with AI. Charles, we're in the future, aren't we, Charles? Isn't it crazy? Oh, accidents happen like that? Yep, Akash, I know. Isn't it crazy? One letter is all it took. I'm like, what's wrong? And here's what I did was I opened up the original, I opened up the original file here, and I was like, what's different? I don't see anything different. And I was like looking at them side by side, and I had them like perfectly lined up like this. And I was like, I can't tell what the difference is. What's going on here? I'm like going line by line, like, they look the same. What's wrong? And it was just one little letter. It was one little letter. It was crazy. At Mega, you missed the first part of the mention of local agent development, automated deployments, and DevOps, though. Yes, among many other things. Yeah, there's a lot to it. Is that not DevOps? It is. I mean, it's DevOps, but now we want to automate DevOps. We want to automate deployment and operations in the full orchestration lifecycle of software. We're getting close, Charles. We're getting close. I'm helping with pronunciation. Oh, gotcha. Okay, gotcha. Okay, so you're talking about go with Kava. Kava. Okay, Kava. That's your name. That's what you're going to be called now. We're going to call you Kava. There we go. Figuring it out. Thank you, Kava. Appreciate it. Octane Rush. What are you coding? We are coding our own deep learning neural network from scratch. We actually finished it in the previous streams. We finished it. And so now we're just playing with it. We're having fun. We're checking it out. We're like, oh, let's do an XOR operator. Let's do this kind of operator. We can do anything now. We can have it run on whatever we want. So as you can see, it's 100% getting the results that we're looking for. It's good. We built it. We're succeeding. We succeeded, you guys. So here comes, Charles W. Good stream, Steven. All the best. Thank you. Hopping off. Good to see you, Charles. Thank you for hanging out. You just gave a bot permission and give it sandbox, and then you automate the team's message. You got it. You got it, Charles. So Octane, that's what we're doing in Octane Rush. We are coding some artificial neural networks. We did it. We did it in the previous stream. Now we're just having fun with it. We're playing around with it. And it's very simple. It's very simple. It's very clean. Make it learn XOR and at the same time. At the same time, can we do it? I don't know if we can do it at the same time because maybe we can. Let me think about that. Can we? We can't because we're training. Can we? Let's think about that for a second. Can it learn both at the same time? It's got conflicting outputs. What we could do is add a second parameter, but it indicates what the operator we need. Actually, I don't know. I'll have to think about that one for a while. It's actually a really good one, Kava. It's a really good one. Can we do multiple operators? I'm not sure. I mean, the answer is yes. We should absolutely be able to do that. How do we do that? I don't know. There's no way for it to know because we're giving it. So we need to change our input and output data. We have to do this. We have to change this here. So how do we do it at the same time? Let's think about that for a second. Hint, you need to introduce more non-linearity. Kava, yes. Okay. Yeah, we need more variables. We need more variables is what the answer is. Akash, why don't you train it on CSV version of MNIST data? Oh, let's do that. Let's do it. I would look to see. Cool in the live stream. All right. So let's grab the CSV. Let's grab it. All right. I don't know if we'll have enough time. But let's see if we can get it. Let's see if we can download the MNIST data set. Let's see. How do we get let's see. MNIST data set. Let's do that. Let's grab that real quick. Let's MNIST data set. Here we go. Let's download it. Where is it? MNIST data set. Let's grab that here. Can we download it? Where is it? Download. Okay. Import. Oh, there we go. I guess we just do it like this. Right here. Download to. Okay. Import Kaggle Hub. All right. So let's try it. Let's see if we can get it work. Okay. Let's see. Pip install. Do I have Kaggle Hub? I don't see Kaggle Hub. Pip install Kaggle Hub. We got Kaggle Hub, and we'll copy this. So pb paste download MNIST MNIST.py. Let's see. Let's open that up real quick. Make sure we're good. All right. Import Kaggle path, and then we just do. I guess. Oh, we know that has to be here. And then wait. Hold on. Oh, we'll just say dot like this. Wait. It's on Kaggle. We got it. We just got it on Kaggle. It would be nice if we could download like a zip or something. Can we download a zip? Is there a way to download a zip here? No, it seems like it's. Oh wait, download a zip right there. It's right there. Oh, I have to sign in. Okay, I have an account. I know I do. Sign in with email. Here we go. There we go. We're signing in, you guys. We're signing in. All right, now let's download it. Let's download the zip file. Here we go. Perfect. We got it, you guys. We got it. Let's open that up. Okay. We've got the archive, training data. Okay, well, there's a lot of data in here. There's a lot of data. Let's see what it looks like. It is in an interesting format. I'm not sure what this format is. Images. 1 second. TK labels. We've got our features and our labels. Images and labels. I'll have to decode it. There's more work to do. I wanted it just to be the image files. Can it just be the images? Why is it giving it into a export metadata, download as data set? Here we go. Maybe, is it over here? Maybe we can get it over here. I'm just trying to see. Wait. I don't know about that. I don't know. Parent directory. There's nothing here. There's nothing there. What is it? MNIST music. It's empty. That's crazy. Okay. Why you cool? It's on Kaggle. Yep. This is interesting. So next is the iris classification for flowers. You want to do it flowers, July, or there you go. We can do flowers next. We can do flowers. .gz. Oh, these are gzip files. Are they? Wait. The MNIST database is handwritten digits, 60,000 examples, and 4 files available. We want this sample reader. I do needs to, let's see here. Let's see, what is this? View more. Okay. We're checking it out. Okay, so what I need to be able to vectorize it. I need to pull in the data. I need to grab the image data. Then I need to vectorize all the samples. So there's some like reshaping that's happening here. Image.reshape. What is, oh, it's reducing the resolution. Okay. It's reducing the resolution so you can train it faster. So let's see here. NumPy, struct array, and then join. Okay. So it looks like we could MNIST downloader. It looks like we can get the data right here by doing this. It looks like we can get data right here by doing this. Where is it? Is it looking? Okay. Image, open with image path. It's been a while. Unpack. Okay. It's got the read. It's got the read there. So it's asking, oh, here's the actual files. Okay. So I have the actual files. Training image data set. Okay. Input path. Verify reading data set. Here we go. Show images. Interesting. Okay. All right. So I should be able to read the data using this approach. Matplotlib. Really? Matplotlib. That's weird. July or oh, wait. This already has data in CSV. Oh, wait. You need just pandas to read this and fit the model. That's what I want, Akash. That's what I want. I already want the data just to be like already nice and formatted for me. We can do 2-dimensional. It's totally fine. We could totally do that. But let me see here. So let's try MNIST data set right here. Input. I want the input view data set. Let's see. Is this, well, here. All right. So I've got the archive here on my hard drive, but it's in a weird format. And I don't know what to do with it. It's not even a GZ file, is it? Are these GZ files? They can't be. Are they? I don't know. I'm looking at it. It's weird. Okay, we're gonna figure this out, you guys. We'll figure this out. Let's see here. Let's go code. There's got to be something. I want it to be really simple and easy. I just want to copy and paste like a quick and easy. You know what? Let's see here. What we could do is just do it the way they were actually asking us to do at the very beginning, where we just copy and paste this. So we get the path, MNIST dataset, Kaggle, download, and then print path. Let's try it. Let's just try it and see what happens. All right. And then I gotta go in a little bit. I gotta get going. You guys, but not right now. Not right now. So let's split this and say it was ls. All right. So let's do Python download. Let's see what that does. So we got it, downloaded it, extracting files. Reference. Okay. Where did it go? Where did the data go? That's what I'm wondering. Where did the data even go? Where is it at? The files path. Okay. Let's open. Let's download, and then let's do this. All right. Let's redo that. Okay. Here it is. Okay. It's in cache version 1. Okay. Let's see what's in this path right here. Okay. 1. Okay. See, look, what is this? It's a whole bunch of obviously this is the image data, but like I don't know how to deal with it. I don't know how to deal with this. Like I just don't know how to deal with this data. Is the thing. I need to be able to understand how to deal with it. So we've got the image, the features, which are the images, and the labels, which are the answers. And so it's just in this weird format. It's in a weird format that I'm not familiar with how to deal with. UByte. It's in a UByte format. I got to deal with this. Back after lunch. What's the progress, buddy? Mr. Lamb, we're playing with the MNIST dataset right now. We're trying to extract it, and then we're going to put it through our deep learning neural network framework, and it should be able to do a pretty good job at predicting the output. We also need to, instead of binary classification, we need multiple classification. What do you call it? I'm not pick a character. Ulavis, hey, how's it going? Welcome on in back. Welcome on in. Happy to see you. What like? How do I deal with it? I just want the basic image data. I just want the basic image data. How do we read this? All right. So I've got the data is downloaded now. I want to be able to read that data. I want to read it, you guys. I want to be able to read it. How to read that file? That's what I want to know. Levis, pick a character. Pick a character. All right, let's pop this open. It's not a thing. Here we go. So we got the data. Import TensorFlow, MNIST. All right, MNIST.load data. See, this is what I want. This is a lot easier. So what we could probably do is just import TensorFlow and then import MNIST. And then I can probably deal with it better that way. I think I can probably better deal with it that way. Let's do that. Let's just go with the TensorFlow approach. This is a lot easier. We won't be using TensorFlow framework, but we are going to use TensorFlow to download the data and import it and load it. Are you familiar with scammer payback? What? That sounds like a malicious activity. That sounds like a malicious activity. What are you talking about? Okay. Let's go over here. Let's close this. Close that. All right. So let's go back to our code here. So we're going to be, let's paste that in. We're only going to import TensorFlow only for the MNIST dataset. We don't need these other things. Wait, what was Keras used for anything? I don't think it was. I think we just need the dataset. We just need MNIST. This is what we need here. That's it. That's all we need. And then we can take care of business from there. There we go. So like this. I do believe I need to pip install TensorFlow. I need to install TensorFlow. There we go. There we go. Installing some TensorFlow. Then we could be able to actually load this data. All right. So let me do print x test. Let's do test. Let's do wait. Print. Let's get this. Print first few samples. There we go. There we go. That's what I'm looking for. Okay. Let's get this, and then we will. Then we can just exit. Let's see. How do we? os.exit. Import os. Let's see if that works. Let's see if that works. Python ml.py. There we go. There we go. Downloading. It's working. Something's happening. Maybe it's working. Maybe it's not. We don't know. It's taking forever. It's taking way too long. What's going on here? Oh, right. It takes a little while to pop open TensorFlow. There it goes. Hey, here we go. Okay, perfect. This is what I was looking for. All this data right here. That's what I want. Okay, we've got part one. Do you know what Dubai chocolate? Oh, yes, with the pistachios. Very tasty. Very tasty, Hannah. Very tasty. Okay, here we go. So that is our data there. So we've got our data. You guys. So we should be able to say x equals x underscore train. Do we need to reshape it, though? I don't think so. I don't think we need to do any. Well, maybe. Let's find out. X. Let's do this. Let's do print x. Let's do it like this. Let's see what happens. All right. Let's run that again. Let's run. Oh, wait. X. Ha. Okay. There we go. Python ml.py. There we go. Python ml.py. All right. Then it's going to load up. Wait, what happened? Module OS has no attribute exit. That's perfectly fine. We are only using it as, let's get rid of that. There we go. And then we've got some layers, and then we're just going to comment these things out for a second. There we go. I actually have an idea. Let's bring this stuff down. Let's bring this stuff down here. Actually, let's bring it, can we? Yeah, we have to, we can bring it down here, I think. So we have a little bit better view on what we're planning to do here. I'm actually quite curious on Pubnub's capital and working capital structure, like your divisions of equity and debt, securities. Good questions. I can say that we're in very good standing, better than most of any company that you've ever heard of. And without violating some trust, what's the MNIST data set? It's a bunch of images. But Mr. Lamb, Mr. Lamb, I'd be happy. Maybe Mr. Lamb, what we could do is we could chat on a private chat at some point, and then we can talk a little bit more details. I won't give away everything, But we could chat. Maybe if you join on Discord, we can chat later and we can jump on a call. We could jump on a call. Okay. What is the MNIST dataset? The MNIST dataset is a bunch of pictures and images. Do I have it up here? Do I have it? MNIST dataset. MNIST dataset. Here we go. It looks like this. Here we go. Let's zoom in. Let's zoom in. Oh, thanks. Here we go. Get that a little bit bigger. It looks like this. So you zoom in. It's a whole bunch of handwritten numbers. And so what you do is see how like 5 is written a bunch of different ways. A bunch of different 5s look like this, and 4s look like this. Sometimes the 4 is open like this, but it's closed like that. So you got a bunch of 4s. So there's a whole bunch of handwritten numbers. And that's what the MNIST dataset is. The idea is it's kind of a hello world for machine learning training an AI model to learn how to recognize what is handwritten letters. And you can then write down on a piece of paper a number, and then you can figure out what its actual value is. And that's what AI does. It helps us figure out things that it's never seen before. You can give it like some new data, and it can accurately predict the outcomes. So it'll be able to predict numbers. That's what the MNIST dataset is. But you know what? We might not have enough time. Mr. Lim, oh, come on, bruv. Some secret. Yeah, I will be happy if we chat secretly, if we chat in private. But yeah, there are some things that we cannot give away because we've been, it's just a way of operating the business. It's just a way of operating the business. It's just certain aspects of it that you don't have to release. I kind of really want to. I want to let you know, but we're collectively agreeing to not mention anything until we get to a certain point. Until we get to a certain point where it will become, in the coming years, it's going to be very exciting, you guys. In the coming years, Mr. Lamb, is going to be very exciting. We'll let you know. It'll be a fun story. Keep watching the stream until then. All right, so here's our X train. There we go. But we are going to have to get going here. I do have to get going. But we got our X input, which is the important part. We got there. So we're so far so good. So far so good. We're looking good here. Did I get rid of here? Let's do this. I knew I was missing something. Here we go. Over here. Like print out the next few samples. And then let's actually go over here so we can pop it open here. So let's do ML. There we go. So let that run for a second. Let it run for a second. Is it open? Okay. So this is what it kind of looks like. So this is a few handwritten numbers. It's a few handwritten numbers. And you see there's the ellipses right here in the center of the screen, some ellipses. That is, there's more, that's where the actual data is. So we're looking good there. But we need probably a bigger model. We probably need a bigger model so that we can, actually, you know what, let's do 8. I'll do 8. Get a few more units there. 8 and 8. There we go. A whole bunch. And then we also need a different output. We need a different kind of output. We need the output to be it's 9, right? It needs to be 9 because, or is it 10? Is it 10 because it's between 0 and 9, right? 0 and 9. So you need 10 output. You need 10 as the output. I think that's what we need. Let's look at the Y. We need to see what the Y train is. Y train _ shape. We need to see what this is. Print. What is the Y train? Let's see here. What is the Y train? We need it. Mr. Lamb, I personally would love to buy some ownership as shares or even invest in bond stocks at PubNub. That's why I'm mildly interested. So there are it's a private company, right? And so we have private shares, and we only create new shares for purchasing during specific events, right? So there are no new shares to buy right now as private. And then when you talk about like an IPO, when you go IPO is an initial public offering, we actually create new shares that can be purchased on an exchange, right? On an exchange. So there are ways to buy private equity, but you need to find someone who is willing to sell their equity, because we are not going to be creating any new shares, right? We're not going to do an IPO, right? We're not going to be we haven't set up an IPO yet, is what I could say. We haven't set one up yet. And so there's no public shares to buy. The only way to buy shares in a private company is to find someone who has shares that are willing to sell them to you. That's the only way to go about it. That's the only way you could do it, Mr. Lamb. Input should be about 784. Whoa, Akash, you know your thing. 784 is a specific number when it comes to the MNIST dataset. You remember the dimensions, Akash. You know things. You've done this before, haven't you? You've done this before. Here we go. Print. Let's see. Let's get the X shape. Let's do, yes, X shape. Here we go. Let's bring that down. Let's do this. A little Y shape there. All right, let's run this. Let's see what happens, you guys. We need to get some data. Okay. Yep. See, look at 784. Isn't that cool? 784, you guys. Y shape. Interesting. Shouldn't the Y shape be... Oh, interesting. So this is where we need to define our model. I need to take a look at what the data of the Y is. Let's look at Y. We need also Y to be Y train. We don't need to reshape it. There we go. Nope. Here we go. F dot. Go to the end. There we go. So there we've got this data. There we go. Yeah, then we're doing this. Here we go. Okay, let's rerun that. Let's see what happens. 784. You guys know what's going on. So Y train's not defined. What do you mean? Oh, because it's a lowercase. It's a lowercase y. Why is it lowercase? Why is the y lowercase? Why is the x uppercase? What's going on there? 504. Okay, so they're actual digit values. That's what the y is. Okay, so how do we do this? We could do a linear output. I don't know how well this will work. It's not going to give us the best result, but we might be able... You're a Vim user. ZOPR. You're a Vim user too? Excellent. We're Vim user. Vim everywhere. Vim is amazing. Vim is the best text editor. I love it. Use the text editor that makes you the happiest. Well, I was not expecting new issues, of course. Oh, Mr. Lamb, you know your stuff. You know about stock, don't you? There will be a limit on the authorized capital. But, yeah, I can talk to a broker bank depository participant to find shareholders in the secondary market. You got it, secondary market. You know your stuff, Mr. Lamb. You seem like you've done this before. You know what you're talking about. You're saying the right words. But yeah, you will have to look at the secondary market in order to get any shares. There you go. That's the way to do it. Jim Gareth, you need to make the Y categorical. Yes, that's the best way to do it, Jim. You know what's going on. We need to make Y categorical. A categorical, you got it. Buy GameStop, Zeto, and osmium. Osmium. Wait, what is osmium? We do have to get going here. Osmium. What is this? Oh, it's like a rare metal. The densest and one of the rarest stable elements on the planet. Thank you for the likes, you guys. TK, I'm not a programmer. What are we doing here? Oh, we're doing artificial intelligence. We've got some, we're doing the MNIST data set. So we've got our X train, which is the image data, which looks like this. Here's the image data, a whole bunch of handwritten numbers, you guys. You get a whole bunch of handwritten numbers, and that's our X data. And our Y data is the values associated with those numbers. So you see the first three values here on screen. The first one is a 5. The next one is a 0, and the next one is a 4. And it's already been randomized, it looks like, hasn't it? So we don't even need to do our own, what is it called? Stochastic. We don't need to randomize it. Real ownership through DRS, the rarest metal ever. Ooh, it is. 1,400 more rare than gold. Is it? That's a lot. Price is 10 times compared. Wow. I had no idea. I thought gold was the most precious metal, but apparently osmium is the most precious metal, you guys. Osmium is the most precious metal. Yes, we need a categorical. We could also do a linear output. So I got it. So we did the categorical right here. Basically, here's the category output. So we got 10 outputs, right? So it's 10. And so what I need to do is convert Y into a 1 hot. Y needs to get converted into a 1 hot. We got to convert Y into a 1 hot shape. So let's see if we can do that. Let's see if we can do that really quick. Python, here we go. How do we do that? So let's do this. Okay. So Y, let's do Y0, right? It's going to be 5, but we need to convert that into a 1 hot. So what's the best way to do that? We can map it, right? We can do y.map, but how do we do that? What's a really good way to one-hot it? We need to create an array that looks like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that. This is what we need to convert it into, something that looks like this, comma, comma, comma. An array that looks like this. It needs to be converted into an array that looks like this. That's what we got to do. So what is a good approach for that? I suppose we can have an index. So we've got a base. So we say a equals this, right? So that's the training, or well, a equals 0, something like that. And then, or wait, y 0, like this. There we go. Did we do it? Did we do it, you guys? Is this? Oh, good night, Steven. It's 11:30 p.m. July, or see you next time. Okay, July, thank you so much for joining in and giving us the idea to do MNIST. We're actually going to we're doing it right now live on stream. But I do got to get going because I got to get going as well. But categorical is the standard approach. But yeah, it would be interesting to see how we could see a linear output would actually perform. We could, Jim. We could totally do it. We could do linear instead of activating a sigmoid output. We could do a linear output and we could have it bind 0 to 10, and it probably will get pretty close. It'll probably get pretty close. It won't perform as good as it could as maybe a categorical, but let's check it out. Is this it? No, wait, no, that didn't. Wait, that didn't. Oh, wait, no. We have to. Almost. Okay, a equals 0, and then we have to say like this. Let me go like that. Let me say a. Let me do y, and 0 equals 1. And then we say A. There we go. So we can do something like this. We can mutate an array. We can make it like that, you guys. We can mutate an array. I'm pretty sure. Is there a way to do it without mutation, though? That's what I want. I want to do it without mutation. Which programming language is best? Python. Java is harder than Python? Yes. Java is harder than Python. La-do. Jim Gareth. There is a convenience function for that, but it's more fun to manually figure it out. It is. There's definitely a convenience function around here somewhere that will convert it into one hot. It will. But what I want is, instead, you see here on the screen that we've got, we're doing A and then we're mutating A. Is there a way to do it without this? I'm wondering. Maybe we could do we can do some list comp. So let's just update A again. So A is this, but not, that's the same thing. We did list comp and A. We do. It would be so nice. It would be so nice. So maybe what we could do is like this, right? We can list comp on this. So we go like that. Bring that back up here. Paste, copy, paste that. Yep. And then, no, get rid of that. Okay. We go like that, right? And then we set for V in this, right? X. Wait, no. Range? Would range work? There's got to be some other approaches. np.i, np.eye. All right, import numpy as np.eye 5. Oh, that looks really cool, but it's the wrong dimension. Let me see. 1 comma. Wait. Oh, you're right. np.i. We could totally do this. Okay, so check it out. 10 and wait, no, not 10. 1 but okay, so 5 here, 1 there, comma. But how do we get it to np.i? We need to be able. It's close. It's almost there. NP Akash, thank you for recommending that. But wouldn't that be slower? I love it. Look into list comprehensions. List comp. Do it without mutation. Jim Gareth, that's what I want to do. I want to do it without mutation, and I want to do it with list comp. I think that's a good way to do it. I think that's a good way. So we've got it here. Where do we go? Did I get rid of it? Where did it go? Where did it go? Let's just bring it back. Okay. There we go. And let me do V in. There we go. So that gets us. Oh, we have to say 4V. V 4V. There we go. So there's that. But how do we? V 0. Okay, here we go. 0. right, 0, or how do we do it? Let's see. Wait. Y. Let's see, y 0. Okay, y 0 equals. Let's see. Oh wait, we can enumerate. This is tough. We're trying to like custom Python function generator would yield or July or that would also work really well. Awesome video. Steven would join again. Tom Collins. Thanks. Next time, watch the full video when I have some time later. Thank you. Very educational. Thanks again, Steven. Happy to help. Tom Collins. Good to see you. Absolutely great to have you. Blum, you probably will answer vaguely. Yes, you got it, Mr. Lamb. You already know what's going to happen, don't you? Don't you, Mr. Lamb? But how much do you give out as dividends? Oh, 0. We don't do dividends. I'll answer you straightforwardly on that one. We're not doing dividends right now, but potentially. So there's a lot of things you can do with a company. All right, check this out, Mr. Lamb. Are you ready? There are a lot of things you can do with a company. When you gain a whole bunch of money and you have like a lot of revenue, right? And you can do a lot of different things with your revenue. You can either pay out to shareholders a dividend, or you can invest that money back into the business, or you can just put it into a bank account with a high yield, or you could do all three, right? You could do all three. So it's really up to us. But right now there's no dividends. We're not doing dividends. We're investing in growth. So the value of the stock is increasing in value. We're increasing the value of the stock. And so all the money that we make, we're reinvesting into the business. There you go. I think that's actually a pretty good earnest to get immense tax benefits. I mean, it's cap gains tax, right? So dividends are cap gains tax. But yeah, you will get some benefits there. Zepto, like issuing warrants, which shouldn't be shortable, but get lent out like GameStop warrants. We could, that's another kind, a warrant is an ability to purchase a share, right? They're kind of like options, but they're different because you're investing a lot up front. There's some difference there. Jim Gareth, if you want to do it with list comp, you will need 2 cops nested. You need a nested cop. Okay. I was wondering about that. So 5, VY, or, let's see, but we could, yeah. So yeah, that's what I was wondering. I know. So this is what I want is if Y is equal, I know I can do it like this, enumerate, but now we're in weird spots, right? So you do I comma, V, and then we go I equals, Y, right? You can do that. Then, and Y, or 0, right? And look, we did it right there. Check it out. I think that's good enough. But it's not going to be Y. It'll be 1 like that. There we go. There's our answer. So we did some list comp. I think we're good enough there. It's not my favorite list comp, but it's good enough. Here we go. Perfect. Here we go. There is our answer. So this will get us part of the way there. Zepto, sorry, GME is my special interest. I will stop that topic now. No worries. All happy here. Wait. Try NPI 5. Oh, Akash. Let's try that really quick. Okay. np.eye. We'll do 10, right? And which gives you this. But if you do 5, there you go. Thank you. That actually does. That's a lot easier, isn't it? That's a lot easier. That is way easier. And so then we could just do Y0 like this. There you go. np.i also works. Okay, so we've got 2 choices. Akash, thank you. This is fantastic. So we got some choices here. This is a lot cleaner. Than this. But the problem is this is generating a whole bunch of data, right? This is generating a bunch of data that we're deleting. So it'll be inefficient. It's inefficient because we're deleting all this data here. So you got this. It's a whole bunch of data that's being generated that we're not using. So there's some inefficiency there. But I like the code is clean and simple, you guys. It's clean and simple. Oh, for range and 10. Oh, that's even better. I like that. Let's do a range 10 instead of a whole bunch of commas and zeros. Let's do that. That's way better. I like, Jim Gareth, I'm going to use your algorithm. I like your algorithm way better. Oh, I got it. So let's do it. Okay, here we go. Let's do, that's how we would do it there, but I like this. We're going to do it. All right. So we'll do it. I'm going to type exactly 1 if I equals j, else 0 for I in range 10, like that, for j in y train. There we go. We're going to use Jim Gareth's approach. Look at all these different options that we got here. We're like figuring out like, how can we get the data in the right shape that we want? There's so many different options. Did you know that you could do it all these different ways? Range 10 is definitely way cleaner. I like range 10. It's definitely way cleaner. Okay, let's pop this out here. And I do believe we can now print this out, which is fine. Okay, let's do this. Let's bring this, let's bring that back here. And then we do Python ml.py. Thank you for all the likes, you guys. Appreciate it. And then here we go. Let's see if it works. Oh, look at that. Look at that, you guys. Beautiful. It's beautiful. And it was fast too, wasn't it? It was fast. Thank you for likes, you guys. Hi, I'm a newbie here. What's going on? Res Publica, we are doing some artificial intelligence. We built our own machine learning neural network from scratch, live on stream. And we did it without using any frameworks other than a helper library called NumPy to help us with things. July or list comprehension, you got it. Add a G corner. Add a G corner. We could add that. That could be a thing. I don't understand anything, but I'm enjoying it. Zen C, excellent. No worries. Thank you for all the likes, you guys. So what we've done here is now we've got the data in the right shape. Now we can actually use it to train our AI model. Isn't that cool? So 784 is the input layer. So I do have to update this. Let's double check. So X, did I reshape? So X and Y. So I have X and Y. Let's do Y. Here we go. So we got Y and X. We're good to go. So we've updated Y and we've updated X. We're good to go on that. So we don't need that anymore. We can get rid of that. We'll leave some of these things here for option later. Now I'm impressed. Wow. Isn't it? It's so cool. Bro writes out of memory. His memory. We've got plenty of memory, Zepto. Plenty of memory. But we also don't want to squander it. That's a good level of coding. I think so. I agree. You are totally right. Okay, let's jump back here really quick. Make sure everything looks good. Okay, shape. We got a problem. Y.shape has no attribute shape. Oh, because it's not a NumPy array. Let's do this. NumPy array. We'll do np.array like this. Array. So that way we've got the data. Let's double check that it looks good. Get it into a NumPy format. Looks good to me. Oh, that's so pretty. Oh, it's so pretty, you guys. Look at that. Oh, it's perfect. It's perfect, you guys. Oh, I love it so much. Okay. So satisfying. Blum, that's quite discouraging in it. I hope when PubNode goes public, you got it. Limited, we'll use more of the retained earnings to pay off dividends. Yes, so that'll be the plan. Right now, of course, we as a shareholder, we want to increase the value of the stock as much as possible. And all shareholders agree that that is the case. And so there's no reason to do dividends right now because we want to increase the value of the stock. And that is how businesses do it. Not all businesses do dividends, but at some point they might. And at the point where you're good to go. And see, even like OpenAI, like they're not doing dividends, right? A lot of companies don't do that. It's Tesla. I'm pretty sure Tesla's not doing dividends. Are they? I actually don't know. Tesla's a public company though. Do I need a linear algebra for this? Res Publica? It kind of helps. It helps. It's not required, but it helps. Or any math topic? Dot size. Oh, we could do a dot size. Eureka. We could do a dot size. That actually is a good idea. Let's actually, I'm kind of curious. Python. Let's do array. Oh, no. Like this. Dot size. Can you do that? List attribute has no size. Oh, well, I guess maybe not. Oh, well. No worries. We're good to go. We got what we wanted here. We have what we want. What are dividends? Mac. Dividends are when you own shares in a company or whatever, some sort of entity, right? You own shares. They per share, they pay you out a dollar amount. For every share that you own in a company, you get paid out a dollar amount. Vibe shift, you love coding. I love coding. I think it's great. We do got to get going though. We've been live for 2 hours. We did good today. We did a lot of things. We got our data in the right shape. Let's see if we can get it into our model really quick. But we can't do 1,000 epochs. We're not going to do 1,000 epochs. That's way too many. Let's see if we can do 1 epoch. 1 epoch. Oh, wait. Actually, you know what? Let's see if we can do 1 epoch. I'm not sure. It's just going to hang the system is all it's going to do. It's just going to hang. Pierre, he's bound by contractual constraints. He can't and won't say out loud. Mr. Lamb, you got it. You got it. What's your company's market cap? There you go. That's the thing. Zeto, well, the private data for now. At some point in the future, I'll tell you all about it. I'm really excited to tell you all about it. But right now, we'll hold it back. 10 will do. 10 will do. Akash, you got it. You got it, Akash. I think so. 10 epochs will do. Yeah, but see, the problem is I think it's going to take a long time. I think it's going to take a while because there's a lot of data. There's just a lot of data. A ton of data. Maybe what we could do is specify just a handful of training inputs and outputs. Let's see if we could do that. Predict result. Let's see if we can just let's see x equals x, and then we'll just do 1,000, and we do the same with y. We'll just do that. Okay, let's do that. So that way it's clean and simple because we have to get going. You guys, we have to get going. Also, the input shape is thank you. Let's do that real quick. 784. Thank you. All right. Let's see if that works. So x.shape. 1 second. Let's see if we can I'm going to see that data. All right. Python ml.py. Let's make sure to type that properly. python, and then double check really quick. Double check. Let me pull this back really quick. We won't do any training yet. Let's go over here. Let's run that really quick. Make sure everything looks good. All right, shape. Okay, so that would be X shape, just in case. I think we're good enough. I think we're good. We're looking good. Okay, let's try it. Let's see if it works. You guys. Oh, we don't need a round, though. We're not going to round. Prediction, model, results, prediction, and results. We don't need results. We just need the prediction. Okay. Let's see. Let's see what we get. Here it goes. It's running, you guys. Oh, we had an issue. Or did we? Did we run into a new issue? Oh, it seems like we ran an overflow encountered in matrix multiplication. Invalid value encountered. We got too big. We went too big, you guys. Let's see. We'll have to reduce it. Let's see if we can reduce it. Well, let's. Oh, because the batch size is too big. We made the batch size too big. Because we need a batcher. You guys, we forgot about the batcher. That's something we're going to do that. Wait, so Blum, during the formation, you guys didn't need to file for underwriting to issue prospectus? Yes, since the shareholders were just a bunch of partnerships. I mean, yes, in a way. So we don't have to divulge any of the information. You're right. None of that information is required to be released. You got it. Jim Gareth, I've got to move on, but always see you live here. It's so good. And just wanted to say that I love your energy and appreciate or the approach, learning and teaching to coding. Cool. Keep it up, man. Happy. Thank you so much. That's excellent feedback. I appreciate it. Have a good one, Jim. Zepto Pierre. All right, we do got to get going. So I'm going to run this once really quick, and then we're going to go. So our batch size was too big. It does look like, so we got something going on here. Let's see here. Still, divide by 0 encountered. We got another problem. Divide by 0. We need to do an epsilon. We need to add epsilon in here. We need an epsilon. Let's see. Epsilon. How do we do that? I think we can do that. Let's see. Plus 0.001 like that. I think we can do that. Maybe. Is that going to be good enough? Do we only have to do it to X? I don't know. Still divide by 0 is a problem. Maybe we can do it to Y as well. So we hit some limitations. Oh, wait, we got an overflow. Divide by 0. Okay. We're getting a whole bunch of problems. So we got to get going, guys. Thank you so much. We'll have to solve it next time. We'll have to solve the problems next time. Thank you for hanging out. We're headed out now. Appreciate everyone for hanging out today. Good stream. We did good today. We had a lot of fun with some artificial intelligence. We got really close, but we hit a limitation. We got some data problems. We got to figure it out. I was thinking maybe adding an epsilon would do the trick, but it didn't. So we'll have to figure out some solutions tomorrow. Thank you for joining, everyone. We'll be back tomorrow. Subscribe to get notified when we go live. It'll be different. We'll be live at a different time tomorrow. And also join the Discord. I should go take a nap, Mr. Lamb. Yes, indeed. There you go. Enjoy the nap. Have fun. Akasha, I guess we got to do that to the params. I think so. I think that's the idea. We might need to do that to params as well. Yo, this was great. Excellent, Zepto. Thank you. We're heading out now. This is the stop stream button right here. We're going to click the button and we're out of here. Good to see you guys. Thank you, Eureka. We'll be back tomorrow. Bye, everybody. We're headed out. Thank you for hosting. Yo.